century corresponded to shrinkage rate of about 15 feet per hour, 15.24 dm. G.B. Dublin, Physics Today, Volume 32, Number 17, 1979. The above findings would indicate that our Sun output of radiant energy is generated by this shrinking and not by hydrogen explosions. Thermonuclear fusion deep within it. As already mentioned, if hydrogen was the so-called solar fuel, we should be receiving a very large quantity of neutrinos, yet almost none are detected. Jupiter is also apparently contracting because it is giving off more heat than it receives from the Sun. A surface of contraction of just 1 centimeter per year would account for the measured heat from Jupiter. A similar situation exists for Saturn. Quote, Jupiter radiates twice as much energy as it absorbs from the Sun through contraction and cooling process. Stardate Radio Broadcast Number 8, 1990. Saturn emits 50% more heat than it absorbs from the Sun. Science Frontiers, Number 73, February 1991. These facts are known, but in order to defend evolutionary theory, the decision has been made to stick with solar fusion. Hydrogen explosions are the cause of solar energy and sunshine. Quote, astronomers were startled and laymen amazed when in 1979 Jack Eddy of the High Altitude Observatory in Boulder, Colorado claimed that the Sun was shrinking at such a rate that if the decline did not reverse, our local star would disappear within 100 million years. John Gribben, The Curious Case of the Shrinking Sun, New Scientist, March 3, 1983. Geological evidence, however, indicates that terrestrial crust, our Earth's rock strata, has an age of several billion years, and it's surely to be expected that the Sun is at least as old as the Earth. We must conclude that another source must be responsible for most of the energy output of a star. Neva Novotny, Introduction to Stellar Atmosphere and Interiors, 1973, page 248. Summarizing solar collapse. The evidence that hydrogen explosion, thermonuclear fusion, is the cause of solar sunshine would be a great abundance of neutrino radiation, but that evidence is missing. The evidence that a solar collapse gradually shrinkage is the cause has been definitely found. Evolutionists reject solar collapse as the cause, since it would mean our Sun and the universe could not be more than a few million years old. 2. The cosmology theories would be wrong, and 3. The Big Bang theory would be gutted. Is there no evidence that supports the Big Bang theory? Evolutionists are able to point to 2. Here they are. Number 1, background radiation, not evidence for the Big Bang. The fact there is a faint amount of heat radiation throughout the outer space is called background radiation. Since it comes uniformly from all directions, it is believed to exist throughout the universe. It is a very small amount of heat, in fact only 2.73 K above absolute zero OK, which is 20 C or 454 Fahrenheit. The theory of background radiation, also called microwave radiation, first discovered in 1965, is said to be the single best evidence that the Big Bang occurred. It is said to be the leftover remains that the last remnant from the Big Bang explosion. Scientists said that the background radiation would prove the theory in 4 ways. Number 1, it would come from only one direction, the Big Bang source. 2, it would have the right radical radiational strength to match the Big Bang mathematical theory. And 3, it would emit the proper spectrum. 4, it would not be a smooth radiation. But we find that if this is the best evidence that the theories can produce for their speculation, it is surely weak. Number 1, it is omnidirectional. Background radiations come from every direction instead of one. The Big Bang theory requires that it come from only one direction from where the Big Bang occurred. Since its discovery, scientists have been unable to match its directional radiation, its isotropy, with the Big Bang predictions. Its omnidirectionality tells where the Big Bang radiation is coming from. Background radiation is actually a slight amount of heat given off by stars throughout the universe. Would they not be expected to emit a very faint amount of heat into outer space? 2. The radiation does not fit the theory, for it is too weak. It would be far more powerful than it is. Fred Hoyle, the leading 20th century astrophysicist, said it should have been much stronger. 3. Background radiation lacks the proper spectrum. It does not have the ideal black body or total light absorption capacity, which would agree with the Max Planck calculation. This radiation does not fit the theoretical 2.67 K black body spectrum required for the Big Bang theory. 4. The spectrum should be far hotter than it is. The heat emitted by the radiation should have a far higher temperature. The radiation should emit 1K black body radiation spectrum, which is far greater than the 2.73K spectrum now has. 5. Background radiation is too smooth. The theory requires that it be much more irregular and lumpy with density fluctuations. In order for it to explain how stars could be formed from the Big Bang explosion, in recent years some slight variations in smoothness have been detected, but this is still not enough to fit the theory. Quote, it seems difficult to believe that whereas visible matter is conspicuously clumpy and clustered on all scales, the invisible intergalactic gas is uniform and homogeneous. J.D. Vucelius, The Case for a Hierarchical Cosmology, Science 167, page 1203. The problem was to reconcile the apparent evenness of the early expansion as indicated by the steady background radiation within the large-scale structures, stars, planets, etc. A perfectly smooth cosmic explosion would have produced only increasingly rarefied, ever-thinner gas cloud. Peter Pocock and Pat Daniels, Galaxies, 1988, page 117. 6. All of the above points, omnidirectionally, very slight amount of heat, generally smoothness with radiation fluctuations in strength is what we would expect from radiational heat from the multiple billions of stars throughout the universe. It would be understandable for all those stars to emit a slight amount of uniform omnidirectional radiative heat, and we would expect the radiational heat emitted by the stars should at great distances show very slight fluctuation. Does not each one send forth heat and occasional gigantic solar flares? If you do not believe stars emit heat into space, then you do not believe the sun keeps you warm. Number 2, the red shift, not evidence for the Big Bang or an expanding universe. The fact relatively white light can be split by a triangular prism of glass into all the colors of the rainbow. Using a spectrometer, this can be done to starlight. Dark vertical bands mark the spectrum at various points. Analyzing these dark bands, the type of elements in each star can be ascertained, and spectral type is a star classification based on its spectrum, surface temperature, and mass. A spectrogram is a photograph of star spectrum. Spectroscopy is the study of spectra. Ultraviolet is one end of the spectrum and has a higher frequency and shorter wavelength than visible blue light. Infrared is the other end of the visible spectrum, as astronomers call it red. Every star is redshifted to some extent, that is, the entire spectrum of that star is moved towards the red end. The farther a star or galaxy is from us, the more its light is shifted. This displacement is called the red. The theory of the Big Bangers, as scientists call them, theorize that this redshift shows that the universe is expanding outward from the source of the Big Bang explosion. They base this on the hypothesis that speed theory of the redshift is the only cause of the redshift. This means that if light is traveling towards us, the wavelength is slightly compressed or shortened. This would cause the light to be blue shifted towards the ultraviolet. If it is moving away from us, the wavelength is stretched out, which causes a redshift, shifted towards the infrared. Quote, this redshift observed in the spectral lines of distant galaxies and interpreted as Doppler speed effect is the key to cosmology. Carl Sagan, Cosmos, page 252. What causes the redshift? Is it quite obvious that the distance of the star from us has something to do with the redshift? Here are 4 scientific explanations for the redshift, each of which are accepted by various scientists. Number 1, the speed redshift, so-called the Doppler theory of redshift. This would occur if the star were moving away from us. Evolutionists say all the stars are moving away from us and that there is no other cause for the recorded redshift, but there are 3 other possibilities. Gravitational redshift. The pull of gravity on the light rays would cause a loss of energy in the beam of moving light. 1915, Albert Einstein predicted that gravity could bend light and that it would cause a redshift. This was later proved to be true. As light travels towards us from distant stars, it passes other stars which slightly slow the beam, causing its spectrum to shift towards the red. Einstein's views of gravity led to the prediction that light emitted by a source possessing a very strong gravitational field should be displaced toward the red, the Einstein shift. Isaac Asimov, Asimov's New Guide to Science, 1984, page 50. Yet in order to bolster the Big Bang and expanding universe theories, evolution ignores gravitational second-order Doppler energy loss shifts. Second-order Doppler shift. A light source moving at right angles to an observer will always be redshifted. This would occur if the universe were moving slowly in a vast circle around a common center. We know that everybody in the universe is orbiting and at the same time moving in some direction with its orbital body. Much of that movement is at right angles to us. Next, energy loss shift. Light waves could themselves directly lose energy as they travel across long distances. This would nicely explain why the farthest stars from us have the most dramatic redshift. This is also called the tired light redshift. Big Bang theories maintain that the speed redshift is the only cause of the redshift because they can then say that the universe is expanding outward as a result of the Big Bang. But the evidence reveals that the speed redshift theory as the only cause of the redshift is wrong. Next, nearly all the stars and galaxies are redshifted. This fact agrees with gravitational loss and second-order Doppler and energy loss redshift. But if only the speed theory is accepted as the cause of this, nearly all the universe is moving away from us, our planet. A true expanding universe theory would mean that everything was moving outward from a common center somewhere, not from one planet. If the Big Bang really occurred, the universe would be rushing outward from where the explosion occurred, not from our planet. Example, a bomb explodes in our space, hurling shrapnel in every direction. A bomb explodes in outer space, hurling shrapnel in every direction. Some pieces would be flying on in our direction, while others traveled in other directions. This differential could be measured. Some pieces would be flying towards us, others sideways and others away from us. If there was a Big Bang, we could date its origin by measuring redshift, but instead we only find evidence that everything in space is redshifted. That is, everything is supposedly moving away from us. This point disproves both the Big Bang and the expanding universe theory. Well, we'll leave it there, folks, and we're on page 98. And I hope that's been of interest to you. I'm going to do the Gospels by a very famous ancient scholar, well, not an ancient scholar, 19th century scholar called Tischendorf. He wrote a masterwork defending the historical Gospels, so I'll be reading out that book later on this evening. And I'll be also going on to Think Tank because he allows you to use his material, and I'll be picking out one or two articles to do something intricate. Like I said, I'm ceased operating on YouTube, making these quick videos. I will be doing Google Hangouts every now and again like this, just something that's got information that's helpful. And I will be making videos, but I'll be putting it on private and releasing them in a year's time. So that's what I'll be doing. So I hope this has been a blessing to you. I hope it's been a challenge, and I hope it encourages you to think through these issues. Thank you for listening, and take care.